Hello, today I'll be doing continuing my physics, yeah. Oh, that's not okay. How do I raise um okay, I did it. Physics, yeah. Physics and topics we're gonna do is work, energy, and power. And I'll be doing two questions, right? So for first we'll do it easy. First it says a wind blowing from east applies a 20 Newton force to a model yacht. What work does the same wind do when it displaces the model yacht 54 meters southwest? So first we're gonna do relevant equation, right? It's just easier to explain like that. Force equals, wait, no, not force. Work equals force times displacement. So first, we know the force is 20 newtons, right? But this equation only works when the force and the displacement in the same direction. So this is going east, right? But the 54 meters is southwest. Let's do that. So that's the 20, right? So we have here 54 meters. This should not be inside the same graph, but whatever. Yeah. So that's gonna be right angle. That's gonna be 45 as we assume southwest is exactly like half the angle. We have to find the displacement here. So easiest way to arrange equations. So sine 45 equals SOHCAHTOA, right? SOHCAHTOA is opposite, so S over 54. So S equals 54 times sine 45. It'd be easier if you do this in your head, but this is more understandable. So now we do our calculate 54 times sine 45, and we get 38.18 meters. And we continue this, so that should equal to 20 times 38.18, and that equals to 763.68 joules, because it's work. And we do the three significant figures because I'm used to doing that for the exam preps. So that's the answer. For the second question, we have a more longer one, right? It says Geoff. Oh no, what is his name, bro? Jeff rides his 213 kilogram motocross bike. Weirdest words ever. Up a 25.3 meter up a 30-degree slope at a constant speed. Calculate A, the energy that the bike's motor expends if the frictional forces opposing the bike's movement is 1/10 the weight. So first, let's calculate the frictional force, right? Because it's not that hard, as it really said, it's 1/10 the weight. So weight is mg, so that means it's 110, 9.8 times 213. It's equal to 213 times 1.8 divided by 10, 208.74 newtons. And now we want to find because look, here's the slope, right? Here's the motor, it's going up. Now for it to be a constant velocity, the acceleration is 0, so there's 0 net force. For there to be 0 net force going up, we have the force have to equal, these two have to equal. So we know that part of this is from friction. The other half is from gravity, because gravity will want to bring the motorcycle down while the motorcycle want to go up. So the gravity is equal to, well, it's supposed to equal to mg sine theta as it's going down, and then you can make a triangle, it's like right angled, and then it's so then, because this is an equation you can memorize, and it might not be on the from the sheet, but it's a good equation to memorize, right? Because sine theta is always like perpendicular, parallel to the slope. Cos theta is always straight down. Yeah, so that's just 213 times 19.8 times sine 30. So that equals to 213 times 9.8 times sine 30. And that equals to 1043.7 newtons. And now they want us to find the energy that the bike expends. So that's basically just work. And we know work equals Fs. And the work is friction plus the gravitational, right? So work equals 1043.7 plus, what is it? 208.74. And the displacement is in the questions because the bike went up 25.3 meters. So that's just equal to with time 25.3, right? And that is equal to 31686.732 joules. That's answer for part A, but we're gonna make it 3.17 times 10 to the power of 1, 2, 3, 4 joules. 3 6 figs, we always do it in exams. Part B, the question asks us, now wants to find out the power output of the bike if the constant speed is 12 meters per second. Okay, so first we know power is work over time. We know work literally just that. So now we need to know what time is. So it gave us a new information of 12 meters per second. So that's velocity, right? This is probably how we probably need to use that to find time. So like basically velocity equals distance over time, right? Because we have both we have this one and this one. So velocity is 12 equals 25.3 over t. T equals 25.3 divided by 12. Because we can just move these to do it easier. Because maths, yeah. 2.108333 seconds. And since power equals power equals work over time, it equals to 31686.732 over 2.108333. The 3's go off up, so yeah. So that equals to 31686.732 divided by answer 15029.28 watts. And we make it 3 sig figs, so that becomes 1.50 times 10 to the power of 1, 2, 3, 4 watts. Yep, that's it for the 2 questions for power, energy, and work. All right, the wrong way around. Same thing. All right, bye bye.